This project is about fall detection using wearable sensor data. Now, the motivation behind this project is about the significance in old age people. More than 50% of the elderly people passed away within 6 months who had experienced long lie. Now, this project is about improving two parameters, which is sensitivity, that is, ability to detect an actual fall, and specificity, which is ability to avoid false positive. Now, the data which was collected for this project was done at SFU. It was taken from 10 subjects across fall, near fall, and ADL. Each trial was of 15 seconds, measuring acceleration, angular velocity, and magnetic field. For the model training, the data summarization was done by actually considering those data points where the actual event took place, which can be seen from the red arrow on the left image. Now I will move on to the dashboard that we created for our data analysis. Now these three graphs, dynamic graphs, corresponds to a single trial. As we can see, these are acceleration, magnetic field, and angular velocity. Now the disturbance in this graph corresponds to the actual event of that trial, and this is the part that we have fed for our model training. Now moving on to the exploratory data analysis, the first three graphs are the static graphs that we have discussed in the previous page. Then the next three graphs are the distribution of subcategories for fall, near fall, ADL. Basically, these are the types of event performed during a trial, like loss of consciousness for a fall. Now I would move on to the machine learning classifiers performances. So we have applied various models from logistic to random forest. The best model seems to be logistic, which got just about zero false positive and a very high true positive rate. Now moving on to our final expected product, which can be seen from these two graphs. The first graph corresponds to the actual data collected in the real time, and the second graph corresponds to the prediction made on the collected data using our trained classifiers. As we can see, whenever there is a disturbance in the real data corresponding to an event of fall, our model detects that fall. Now this project has the capability to scale to a fully fledged application with computation done on the cloud on the streaming data reported from sensors. Finally, these are our contact information in case additional clarification is required. Thank you.